Quantum computing is a transformative field in the fields of computing that leverages the principles of quantum mechanics and phenomena like quantum superposition principle, quantum interference, and quantum entanglement to perform computations that are infeasible for classical computer. Quantum computing is widely applicable in various fields like engineering, physics, and chemistry for performing difficult computations with exponential speed. Let's try to understand some key components of quantum computing. The first component of quantum computing is qubit. The other key components are quantum gates, quantum circuits, measurements, quantum superposition, quantum entanglement, quantum interference, to name a few. What are qubits? In classical computers, the component is bit or binary digit, which are 0 or 1, that is state 0 and state 1. But in case of quantum computers, the unit of quantum information is qubit or quantum bits. So unlike the bits in classical computers, qubits are constituted with not only the quantum states 0 and 1, but infinite number of superposition states of quantum state 0 and quantum state 1. Another key component of quantum computing is quantum gates. Now, quantum gates are basically unitary matrices that are applied or implemented on qubits in a quantum circuit. Now, these quantum states, which are unitary matrices, can transform other quantum states into another state with the help of unitary operations. Another key component of quantum computing is quantum circuit. The quantum circuit is basically comprising of qubits, quantum gates, and the measurement operation in the end of the circuit. So, in the beginning of the quantum circuit, the qubits are placed, and in the middle section of the quantum circuit, the quantum gates are implemented or applied to the qubits for the transformation of several quantum states to another state or target states. Then the final section of the quantum circuit is the measurement part that is implemented after the application of quantum gates. Let's try to understand why quantum computing is useful in the fields of engineering, physics, and chemistry, and other science and technology fields. Quantum computing brings the exponential speed up in case of computations of problems. The reason behind the exponential speed up of computations in quantum computers is the quantum superposition principle. As per this principle, in case of quantum computers, the qubits can assume not only the quantum states 0 or 1, but infinite number of superposition states of 0 and 1 simultaneously. This is the reason behind the exponential speed up of computations in quantum. There are several applications of quantum computing in various fields. Quantum computing is very much applicable in engineering and science, such as physics, chemistry, and other fields. It is very much useful in the fields of in the medical fields as well. In case of drug designing, it's very much useful in cryptography, artificial intelligence, machine learning, material science, chemistry, physics, in case of drug designing also, and other things. There are several quantum computing analogs of the machine learning algorithms which are very much useful in computing several difficult problems. Quantum computing is a blessing in case of computing several difficult problems within very small time scale, as it provides the exponential speed up. There are several quantum gates which are implemented in quantum circuits Some of those gates are Pauli X gate, Pauli Y gate, Pauli Z gates, Toffoli gates, Hadamard gates, control quantum gates, to name a few. These gates are pretty much useful in transforming the quantum states into another states with the help of unitary operations. That's all about the brief understanding of quantum computing in this video.